here is the second part to concept number 4. This is number 11. You try this problem. So when you graph it, it is a function, and then the inverse is y equals the cubed root of the quantity of x plus 2 over 3. Okay. I'm going to go ahead and move on to concept number 5. Pause that if you need more time to look at that. Okay, so here we go. Concept number 5, finding the inverse of a radical function. It says, consider the function f of x equals 2 times the square root of x minus 3. Determine whether the inverse of the function f is a function, then find the inverse. Okay, so I am going to go ahead and graph it to determine whether it is a function. I made a table right here. And really what I'm going to do is look for perfect squares. Alright, and if I look for perfect squares, then I don't even need to use my calculator. Right, so if I put net 3 right here, right, I get 3 minus 3, which is 0. The square root of 0 times 2 is just 0. Alright, if I put 4 in, I get 4 minus 3, which is 1. The square root of 1 is 1 times 2 is 2. If I put 7 in there, I get 7 minus 3, which is 4. And the square root of 4 is 2 times 2 is 4. I'm going to go ahead and just throw in another one, but I'm going to put 10 in here, and then that one's not going to work, right? So I get 10 minus 3, which is the square root of 7, which if I plug in my calculator and multiply that by 2, I get 5.3. And last, if I put 12 in here, 12 minus 3 is 9. The square root of 9 is 3. 3 times 2 is 6. Okay, so really just getting an idea. You wouldn't probably even need that one right there. Just putting it in there so you can recognize. Okay, so 3, 0. I go 3 to the right. 1, 2, 3. And stop. 4, 2. I go 4 to the right. Up 2. 7, 4. I go 5, 6, 7. Up 1, 2, 3, 4. 10. 5.3. Around there. 12's off, but right around there. Okay, so looks something like this. Okay, I'm going to label it F. And there is the graph. Now, is this a function? Does it pass the horizontal line test? Yes. Okay, so we know the inverse is a function. Okay, perfect. So now, what is this inverse? Alright, so I'm just going to go ahead and use a different color, but basically, again, I'm going to replace y with f of x, or f of x with y, 2 times the square root of x minus 3. Now I'm going to flip the order of the x and y. And I'm going to start by dividing everything by 2. Now I get the square root of y minus 3 equals x over 2. I'm going to square both sides of the equation, leaving me with just the quantity of y minus 3. I'm going to take x squared. X times x is x squared, and 2 times 2 is 4. Alright, and then I'm going to add 3 to both sides. So I'm kind of running out of room here. I just y minus 3 equals x squared over 4. Add 3 to both sides. Cancels out. I am left with y equals x squared over 4 plus 3. And there is the inverse right there. And if I were to graph the inverse, right, it would actually be over here, right, because it's reflecting over that y-axis. Okay, go ahead and do number 13. Take your time, work through it. Again, you're going to graph. All right, you're going to determine whether the inverse is a function or not, and then you're going to find the inverse. And I'm going to go ahead and show that to you now, so pause it up. Alright, here is the answer. Number 13. Graphed it, it does pass the horizontal line test. So the inverse is a function, and then y equals x squared over 9 minus 4 for your inverse. Okay, pause it. If you need more time with that, I'm going to go ahead and flip it up. And we got one more skill. And here we go. Inverse functions undo each other. So when you evaluate a function to specify input, then evaluate its inverse using the output. You obtain the original input. When you obtain the original input, let f and g be inverse functions. So in general, f of g of x equals x, and also g of f of x equals x. So that's what you're going to do. You're going to basically do f of g of x, and if it equals x, you're going to do also g of f of x and it equals x, then yes, they are inverses. Okay? Alright, so here we go. F of g of x. Okay, here's how it looks like. Okay, so I take the g of x, right, and I'm going to say f of g of x, which is the x plus 1 over 3. And then I'm going to take f of g of x, so now I'm going to take that g of x, right, or this x plus 1 over 3, and I'm going to plug it in for x in the f of x function. 3 times 1 plus x over 3 minus 1. Okay, so there's f of g of x. Now I go ahead and simplify, so I'm going to multiply that 3 in there, but really I'm just going to cross that out, so it cross cancels. And now I'm left with x plus 1 minus 1, and positive and negative 1 is going to cancel out, and I am left with just x. So far so good. Now I'm going to do the opposite of that. I'm going to do g of f of x. Okay, so g of x right here, f of x here, so I'm going to do g of f of x, so 3x minus 1. And now I put that 3x minus 1 up here into the g of x function for x, and I get 3x minus 1 plus 1 all over 3. Okay, I'm going to start with the numerator. Negative 1, positive 1 is going to cancel out. I am left with 3x over 3. Cancel out that 3 right there. 3 divided by 3 is 1. 1 times x is just x. And now you can see that f of g of x is x, g of f of x is x. So yes, they are inverse functions. Okay, 15 is the last problem of Chapter 5 notes. Give it a try. I'm going to go ahead and show you right here. There is our answer. The answer is yes. F of g of x equals x, and g of f of x equals x. They are inverse functions.